In this video, we're going to look at the autoionization of water. Now, in the previous videos, we said that water is amphoteric. That is, it can act as both an acid and a base. Therefore, what that means is when you just have a sample of water, there will be some ions present because it will have an acid-base reaction with itself. We call that acid-base reaction with itself autoionization, where H2O plus another molecule of H2O make H3O plus and OH minus. And generally, we just write the autoionization of water as H2O goes to H plus OH minus. Right? Now, any aqueous solution, any solution that has water in it, has both H3O plus and OH minus. And these concentrations are equal in pure water. If you have a sample of just water, the amount of H3O plus and OH minus will be the same. And at 25 degrees C, these concentrations will equal 10 to the minus 7 molar. Now, what's interesting is that if you multiply the concentration of H3O plus by the concentration of OH minus, you'll always get the same number at the same temperature. And this is known as Kw, another K, or the ion product of water, or the dissociation constant of water. So it has many different names, but the symbol is Kw. And at 25 C, if you multiply the concentration of H3O plus by the concentration of OH minus, again we call that Kw, that is equal to 1 times 10 to the minus 14th. What that means is, if we know the concentration of H3O plus, then we know the concentration of OH minus automatically by solving this equation, and vice versa. If we know the concentration of OH minus, if we know the temperature, we must know H3O plus as well, because we know what Kw is. And what this also means is, as you increase one concentration, the other concentration must decrease, because these two numbers must always give you Kw. Therefore, we will say these concentrations are inversely proportional. As one increases, the other one decreases. Now, this brings us to what is known as pH. And here, I just have a list of different things with different pHs. So you see your stomach acid has a very low pH, which means very acidic. We have your wine here, your beer, very acidic. Human blood, a little basic. Egg whites, milk and magnesia, ammonia, very basic. And what this pH means, pH actually means minus log of your H3O plus concentration. So every time you see a lowercase p like this, what this means mathematically is minus log. And to type this into your calculator, you literally do minus sign log or log minus sign, depending on what brand of calculator you have. And so in pure water, we know the concentration of H3O plus is 10 to the minus 7. If we type in minus log 10 to the minus 7, we get a pH of 7. This shouldn't be a surprise to people. Pure water has a pH of 7. Now we know the chemical reason why and the mathematical reason why. So as long as we know the H3O plus concentration, using this equation, we can calculate pHs of solutions. And we say anything below 7 is acidic, because it has more H3O plus than OH minus. Anything greater than 7 is basic. It has more OH minus than H3O plus, and anything 7 is neutral. The amount of H3O plus and OH minus is the same. All right. So H3O plus equals 10 raised to the power of minus pH. These are the equivalent expressions. So to get rid of a log in mathematical terms, you just raise each side to the power of 10. So to solve this, to just get H3O plus concentration alone, the first thing we're going to do is multiply each side by a -1 to get the negative side gone. Raise each side to the power of 10. When you raise log to the power of 10, it gets canceled out, and that's how we get this expression H3O plus equals 10 raised to the power of minus log. Now we know Kw is equal to this expression at 25C. In neutral, like I said, the concentrations are equal. Acidic, H3O plus is dominant. Basic, OH minus is dominant. And so what do these pH numbers mean? So the pH numbers means it's more acidic. But since we're on a log scale, that means one pH unit has 10 times the amount of H3O plus. So going from 7 to 6, 7 to 6 has 10 times more H3O plus. 7 to 5 has 100 times more H3O plus. 7 to 4 has 1,000 times more H3O plus. And generally, we think of pH between 0 and 14. It is possible to have negative pH and numbers bigger than 14, though. Unlikely, but possible. Okay. Like pH, we can also have pOH, which is basically the same thing. Remember, this P means minus log. So pOH is minus log of OH. And then we can say OH equals 10 raised to the power of minus pOH, as I went through on the previous slide. And we know at neutral conditions, pOH must equal to 7. So to find pOH, we need the OH concentration. So if pOH is less than 7, we're basic. We have an abundance of OH minus. pOH greater than 7 is acidic, and pOH at 7 is neutral. What is interesting about this is if we know pH, we can find out pOH, because pH plus pOH equals 14. Just like how we said H3O plus concentration multiplied by OH minus concentration equals 1 times 10 to the minus 14, well, pH plus pOH equals 14 as well. So let's actually walk through some problems like this. So let's say I want to find OH minus when H3O plus are these concentrations. How do I do that? Well, I use my expression H3O plus multiplied by OH minus equals 10 to the minus 14. I plug in my known. I just solve for OH in both cases. Okay, how about this? What is pH and pOH at 25C when given an H3O plus concentration? Well, again, I know this expression, pH plus pOH equals 14. pH is just minus log of my H concentration, which is 7.8. I plug my pH back into this equation. I get 6.2 out as my pOH. And I do the same thing for my other equation. I get 7.2 as my pOH. Now with this information about pH and pOH, we can actually go back to our acids and bases and calculate pK or pKa. So pKa and pKb, again, P is just minus log, so pKa is minus log Ka. pKb is minus log Kb, therefore Kb is 10 raised to the power minus pKa, and Kb is 10 to the power minus pKb. And the stronger the acid you have, the smaller your pKa. So a large Ka will give you a small pKa. And the stronger the base, the smaller the pKb. So keep that in mind. If you have a big Ka or a big Kb, you have a strong acid or a strong base. That means you will have a small Ka or a small Kb. And that's it for this video. I will see you in the next video.